The diagram shows part of the graph y equals 4e to the 2x plus 16e to the negative 2x, meeting the y-axis at the point A and the line x equals 1 at the point B. Find the coordinates of A. Well, clearly it's a y-intercept, so x is equal to 0, and that means y would be 4e to the 0, which is just 4, plus 16e to the 0, which is 16, which is 20. So A is the point 0, 20. So we will now want the y-coordinate of B. Well, that's when x is equal to 1. So y is going to be 4e squared plus 16e to the negative 2. And we could state that exactly as the, we only want the y-coordinate, we don't want coordinates. And we could just make that into 4e squared plus 16 over e squared. I don't think there's any need to dive into the calculator at that point. So in part 3 we want to integrate, and we know how to integrate exponentials. The power doesn't change. So we get 4e to the 2x, but we do have to use the chain rule when we differentiate, which means multiplying by 2. So here when we're integrating, we'd need to divide by 2. And then we'd have 16e to the negative 2x, and by the same token, you divide there, and don't forget the constant, and now we can tidy. So that's 2e to the 2x, take away 8e to the negative 2x, plus a constant. And hence we want to find the area of the shaded region enclosed by the curve and the line AB, so this bit here. So we need a strategy, and basically that strategy is going to be that this is a trapezium, and then this bit I'm shading here is the area under the curve, and if we do the trapezium take away the area under the curve, that would give us the answer. So if we think about that trapezium, we know that this length is 20. There's probably time to actually evaluate that on the calculator. So what was it, 4 multiplied by e squared plus 16 divided by e squared. So that's 31.72. I actually might write that answer just there. And so the parallel sides for our trapezium are 20 and 31.72. So we've got a half, some of the parallel sides, and nicely I've got that one in the calculator, and then the distance between them is 1. And then we want to take away the integral from 0 to 1 of 4e to the 2x plus 16e to the negative 2x dx. Okay, so the first part's easy enough. So what do we got? We've got a half multiplied by 20 plus the last answer times 1. So it's 25.8608. Take away, and we know this is the integral, so we've got 2e to the 2x, take away 8e to the negative 2x, which is 8 over e to the 2x, and we want to evaluate that from 0 to 1. So it's 25.8608, take away. Now, using 1, we've got 2e squared, take away 8 over e squared. Using 0, we have 2, take away 8. So I think we can do that pretty much as one calculation now. We've stepped it out enough, we've shown what we're doing. So we've got our last answer, take away. So in this bracket I want 2 multiplied by e squared, take away 8 divided by e squared, and then we're going to take away essentially -6. And that gives me 6.17 square units to 2 decimal places.